Hey everybody, this is Mr. Aynesworth. Good morning. We are going to get right into a little demonstration here, how to handle activity 3B3 and MRWC. Alright, so let's get started. Get your red pen out because we're going to annotate a little bit. And let's read it first. We got two different people going on here. This is the Anne and Simon activity, okay? Anne and Simon use different methods, okay? Different methods to simplify their homework problems. Both methods are correct, okay? So both are correct, and their answers match. Simon thinks his methods are more efficient. Okay, now typically efficient means faster, okay? And in this case, faster means less steps. So faster, less steps. So if you're more efficient, you do it faster, which in this case, and mathematically speaking, we're doing it with less steps. And maybe it also implies maybe even easier. At least it means for him, okay? So faster and less steps means efficient. With your partner, work through both Anne and Simon's problems for each expression and compare the two methods. So what I want you guys to do is label each step for both students and try to understand what in the world they are doing, okay? So you're going to strive to understand both methods. Strive to understand both methods, okay? Both. So we're trying to learn different ways of doing things. Okay, so let's get started. Let's analyze Anne first, and then we'll analyze Simon. Okay, so on the left, we have Anne, okay? And on the right, we've got Simon. All right, so just keep that in mind. Anne's on the left. All right, Simon's on the right. All right, so here we go. All right, get your red pen and let's annotate. So what did we do here? So step 1, 2, 3, 4, and 5. So we got step 1 is here, step 2, step 3, step 4. Let's line them up here. Step 3, step 4, step 5. Guys, there's only 5 steps. All right. Okay, so notice we start off with the original expression here, 3 root 5 times quantity, root 10 plus 2 root 15. So how in the world did Anne get 3 root 50? Well, if you think about it, she multiplied through, right? That's called distributive property, guys. Root 5 times root 10 is root 50. And root 5 times root 15 is root 75. So when she multiplied through, which is using the distributive property, root 5 times root 10 is root 50. And then root 5 times root 15 gives you that second root, root 75. So she used the distributive property. Okay, what did she do after that? Well, let me see. 50 changed to 25 times 2. That's called factoring. So she factored each root. Or you can say she split the root into its factors. In class, we say split the root, but we're talking about factoring the number. 50 is the same thing as 25 times 2. 75 is the same thing as 25 times 3. So what she's doing is she's factoring, people, okay? All right, so factor each root. All right, what does she do after that? Well, let me see. The square root of 25 is 5, and the square root of 25 is 5 here. So she simplified, all right, simplify each root. We know the square root of 25 is 5 on both cases, so she's just simplifying. All right, and then 3 times 5 is 15. 6 times 5 is 30, so she's simplifying even further. All right, simplify, or you can say multiplied. Okay, she multiplied 3 times 5 to 15, 6 times 5 to get 30, so she simplified or multiplied. And then after that, what'd she do? What'd she do? Look at this. This 15 came out of the two terms here. Whenever you see a common factor, like 15 is divisible into 15 and 30, all right, you factor out what's called a GCF. Okay, this is a skill, a big time skill. All right, this is an important one, so let's start. Factor out the greatest common factor. That is done all the time. So she factored out the GCF. All right, 15 and 30 are both divisible by 15, so factor it out. It's called the GCF. Now, what does Simon do? He didn't distribute through. No, he didn't. He simply factored first. And then, so look at this. Root 10 is root 5 times root 2. Root 15 is root 5 times root 3. So he factored each root first. All right, so let's say factor first. Step 2, look at that. He's only got 3 steps. He's more efficient. Okay, so less steps, more efficient. He does a lot of mental math. Okay, and then what do you do? Let me see. What's in common here? Look inside the parentheses. The root 5 is in common. So in then step 2, he factored out the GCF of root 5. Look at that. He factored it out. Factor out GCF. Again, I told you guys that this right here, this technique is used a lot. And then after that, what do you do? Let me see. Well, root 5 times root 5 is 5. Times 3 is 15. So what he did was he simplified. See these two right here? Okay, you can multiply those together. So root 5 times root 5 is 5. 5 times 3 is 15, and that's how they got the 15. So he multiplied and simplified. So multiplied and simplified. Okay, which is something we do in mathematics. We multiply and simplify. All right, so there we go. So I think in this case here, both got the correct answer. Both know what they're doing, but both have two radically different approaches. All right, Anne is methodical. She was trained to distribute each time, and that's what she did. All right, it took her 5 steps to do it. Simon, well, he factored first, factored out the GCF, and then multiplied, and did it in 2 less steps. So he's more efficient. All right, so, but you know, either one's good, right? Both got to the same result. Both are correct. It just so happens that Simon does it a little bit more efficiently, meaning less steps. All right, and that's how you approach this entire activity. All right, and since there's quite a bit here, it's 2 pages long. All right, and so you're going to do a final critique and summary on the 2nd page here after you go through problem number 7. There's 7 of them here. So what I'll do is I'll illustrate one more time the difference between the two. All right, just give you another feel of what's going on. Unless you want to stop the video now and do it on your own, that's fine with me. All right, but I'm going to take you through one more time, okay? So let's analyze the 1, 2, 3, 4, 5, 6 steps, and this is Anne now. And this over here is Simon. Okay. Let's see here. So what did she do? Well, she distributed again. Okay, she's a distributive property person. Okay, so she just does that every single time, it looks like. So distribute first. All right. And then, well, 6 times 18, well, that's 108. And then 6 times 8, well, that's 48. So she multiplied here and here. Okay, so she multiplied. So you have to just analyze what in the world they did. All right, you distribute, and distribute means multiply anyways. All right, so you have to multiply the roots. Okay, multiply the roots. Root 8 times root 18 is root 108. Root 6 times root 8 is root 48. You simply multiply. All right, now to get from 108 to 36 times 3, well, guess what? You factor. All right, so this person, or Anne, okay, factor the root. Factor each root. Okay, then what did she do? Well, let's see here. Let's analyze. So let me see. Root 36 became 6. Root 16 became 4. So you simplify the root. Okay, like I said, I want you guys to strive to understand what they did, because this is what you guys are going to be doing on your own when I ask you guys to simplify the expression. You got to pick a method here that works for you, either Anne or Simon, and then go for it, run with it. And then what happens here? Well, 6 times 10 is 60. 6 times 4 is 24. So she multiplied and simplified. Multiply and simplify. Okay? And then right here, if you have 60 root 3's minus 24 root 3's, well, you have, guess what? You have 36 root 3's remaining. All right, so you simplify, all right, or you combine roots. combine like roots. Okay, they're like roots. They're all root 3s. You can combine like roots. All right, but you can't combine unlike roots. Like if this was 60 root 3 and the other one was 20 root 2, well, then you couldn't do that because there would be unlike. Here they're like terms, and so you can combine like terms. All right, just like variables, well, roots act the same way. All right, now how did Simon approach this? Well, let's figure this out. So 1, 2, 3, 4, 5, 6. He did it in 6 steps too. So they're both the same in terms of number of steps, but they're done differently. See, he in the first one here, he factored each root first. Where Anne keeps on distributing first, Simon factors first. And so he factors. So 18 is 9 times 2. Look at that. 8, well, guess what? It's 4 times 2. So you factor each root. Factor each root. This is his style. This is his method. And then what happens? Well, you take root 9 and you simplify it to root 3. Root 4 is the same as root 2. So you simplify the root. Okay, he knows how to simplify roots just like you do. All right, and then what did we do? Well, 5 times 3 is 15, and 3 times 2 is typically 6. So you multiply and simplify. Okay, so you multiply / simplify. Okay, as I keep on saying. All right, 5 times 3 is 15. 3 times 5 is 6. Notice how I'm color coding everything too, so you can see it. And then what? Well, here, these are like terms, right? 15 root 2 minus 6 root 2 is 9 root 2. So you combine like terms. So let's say that. So combine like terms. You can also say simplify. That would also work. Okay. Step 5, what they do? Well, let's see. What they do? So, looks like he went from root 6 to root 3 times root 2. Okay, so he factored again. So he factored root. Got to spell properly here. So factor the root. That's what he did. Okay, he went from root 6 to root 3 times root 2. They're the same, right? Root 6 is the same as root 2. And then that's step 5. Let's see. 1, 2, 3, 4. Well, I got the steps mixed up here. Let me think about this. So factor each root is first. Simplified each root is the second in green. Third, multiply and simplify. And then step 4. We combine like terms and factor. So step 4 is he did both of those things. So he did 2 things here. So this one and this one, step 4 here. So we combine like terms. 15 root 2 minus 6 root 2 is 9 root 2. That's combining like terms. And then he also factored root 6 into root 3 times root 2. So there was 2 things done there. And then step 5 is here. What happened? Well, let's see. What happened? You got to analyze. So, he rearranged things. Look at this. So he multiplied the roots, the like roots. Root 2 times root 2 is 2. Look at that. And then he brought the 9 in front and just rearranged terms. So he multiplied the roots. So I'm going to write down root 5, or in step 5 here. So here we go. So he multiplied like roots. So multiplied like roots. Okay. And rearranged terms. And then the last step here, all right, number 6, you simply multiply 2 times 9 times 2 is 36. All right, so you multiply and simplify. Because that's what we do in mathematics, right? I mean, obviously, guys, you multiply these 3 numbers here and you get 36. 2 times 9 is 18, times 2 is 36. And that's called multiplying and simplifying. So when you go through the activity, my friends, okay, you understand both methods, and you want to figure out which one's more efficient. All right, you want to figure out what they're doing, and then you got to figure out, what suits you the best. What What method do you prefer? Because you're going to be doing this on your own here in a little bit. After this activity, you're doing it on your own. So this kind of teaches you the different ways to respond to radicals, which are roots, right here, in different ways. And so are you going to be more like Anne, or are you going to be more like Simon? You got to make that decision. All right? And this is Mr. Aynesworth. I'll see you in my next lesson. All right? Or on class. Take care. Bye-bye.